What if you could build a fully functional AI agent? One that browses the web, writes code, executes tasks, and solves real problems, using nothing but plain English, no computer science degree, no years of Python experience, just a tool called Cursor and the right workflow. In the next hour, that's exactly what you're going to do. I'm talking about a complete AI agent, one that takes a goal, breaks it into steps, runs code, checks the results, fixes its own mistakes, and delivers a finished product. And you are going to build it from scratch, step by step, right here, right now. So let's talk about what Cursor actually is. Cursor is an AI-powered code editor built on top of Visual Studio Code. Calling it just a code editor is like calling a Tesla just a car. Cursor has a built-in AI that understands your entire code base, answers questions, writes code, and, most importantly for this tutorial, builds AI agents. The reason developers and entrepreneurs are switching to Cursor by the thousands is simple. It collapses the distance between an idea and a working product. What used to take a senior developer 3 days now takes a beginner 3 hours. That's the power shift we're talking about. Here's what you're going to walk away with today. A fully operational AI agent built inside Cursor that can accept a goal, research information, write and execute code, and return a complete result. This is the kind of project that lands freelance clients, powers SaaS products, and gets engineers promoted. Let's start with installation. Open your browser and go to cursor.com. You'll see a big download button right in the center of the homepage. Click it. Cursor will detect your operating system automatically, whether you're on Mac, Windows, or Linux, and download the right version. This download takes about 30 seconds. Once the download finishes, open the installer. On Mac, drag Cursor into your Applications folder. On Windows, run the Setup Wizard and accept the defaults. On Linux, follow the app image or deb package instructions. After installation, launch Cursor. First launch takes about 10 seconds while it sets up its AI systems. When Cursor opens for the first time, it asks you to sign in or create an account. Click Sign Up. Enter your email address, create a password, and verify your email. Once verified, Cursor gives you a free trial of the Pro plan, which includes access to all the AI features we need for this tutorial. After signing in, Cursor asks if you want to import your VS Code settings. If you use VS Code, click Import Settings. This brings over your themes, extensions, and keyboard shortcuts. If you're brand new, click Start Fresh. Either way, you'll land in the Cursor workspace. Let's take a 60-second tour of the Cursor interface before we start building. On the left side, you see the File Explorer panel. This shows all the files in your current project. On the right is the main editor, where you'll write and view code. At the bottom, you'll see a terminal panel, which is where your code actually runs. The most important part of Cursor for this tutorial is the AI chat panel. You can open it with the keyboard shortcut Command-L on Mac or Control-L on Windows. This panel is where you talk to the AI, give it instructions, and watch it build your agent. Think of it as having a senior developer sitting next to you, available 24/7. There's also a feature called Cursor Composer, accessible with Command-Shift-I on Mac or Control-Shift-I on Windows. Composer is different from the chat. It can edit multiple files simultaneously, run commands, and orchestrate complex builds. This is the power tool we'll use to build our AI agent. The first core feature is Cursor Chat. Open it now with Command-L. You'll see a text input at the bottom. Type this exactly. Explain the project structure I should use to build a Python AI agent. Press Enter. Watch what happens. Cursor reads your entire environment context and gives you a structured, specific answer tailored to your setup. This is not a generic ChatGPT response. This is context-aware AI. Notice that when Cursor responds in the chat, it shows you which files it referenced and why. This is called context transparency. Always check the files Cursor pulls in. If it's pulling in the wrong files, you can add the right ones by pressing the @ symbol and selecting the file you want. This is your first professional shortcut for working efficiently with Cursor. The second core feature is inline editing. This is where Cursor becomes magical for building agents. Click anywhere in a code file and press Command-K on Mac or Control-K on Windows. A small input bar appears right inside the editor. Type an instruction. For example, add error handling to this function, and watch Cursor rewrite just that section of code without touching anything else. This surgical precision is what separates Cursor from every other AI tool. Here's a common mistake beginners make with inline editing. They give vague instructions like, make this better. Always be specific. Instead say, add a try except block that catches val arrayber and logs the error to a file called agent, log. Specific instructions get precise results. Vague instructions get generic code. The third core feature, and the one we'll live in today, is Cursor Composer. Press Command-Shift-I to open it. Composer is a multi-file AI agent that can read your entire project, make changes across 10 files simultaneously, run terminal commands, and verify results. For building an AI agent inside Cursor, Composer is your primary workspace. When you open Composer, you'll see it has its own conversation history on the left side. Each conversation is a session. Create a new session by clicking the plus icon at the top of the Composer panel. Name this session AI Agent Build. This helps you stay organized as your project grows across multiple sessions. The fourth core feature is called Rules for AI, and most people have no idea it exists. Go to Cursor Settings by pressing Command, on Mac, or Control, on Windows. In the Settings panel, click on AI in the left sidebar, then scroll down to find Rules for AI. This is where you set permanent instructions that apply to every single AI interaction in your project. In the Rules for AI field, type these instructions. Always write Python 3. 11 compatible code. Use clear variable names. Add docstrings to every function. When building agents, use langchain as the framework unless specified otherwise. Always include error handling. These rules act like a persistent system prompt that shapes every response Cursor gives you. For this project, this is an expert-level technique that saves hours of corrections. Now let's talk about prompting Cursor effectively. Because the quality of your prompts determines the quality of your agent, there is a framework called STAR prompting that professional Cursor users follow. STAR stands for Situation, Task, Action, and Result. Let me show you how to use it. Here's an example of a weak prompt. Build me an AI agent. Here's the same request using STAR. Situation. I have an empty Python project. Task. Build a research AI agent. Action. Create agent. PAY, with a research agent class that accepts a query, searches the web using the SERPer API, summarizes results using OpenAI, and returns a structured response. Result. The agent should handle errors gracefully and log all actions to agent. Log. See the difference? That second prompt gives Cursor everything it needs to succeed. All right, let's build the real thing. We are building a research AI agent that takes a topic, searches the web for the 5 most relevant articles, summarizes each article using AI, ranks the summaries by relevance, and outputs a clean research report as a text file. This is a real-world, deployable, monetizable product. First step is project planning. In Composer, type this message. I want to build a Python research AI agent. The agent should 1. Accept a research topic from the user. 2. Search for the top 5 web results using SERPer API. 3. Scrape and summarize each article using OpenAI. 4. Rank results by relevance. 5. Export a research report to report. TXT. Please plan the file structure and list all Python packages we will need. Press Enter and read the plan Cursor generates before touching a single file. Cursor will suggest a file structure like this. Agent. P agent. For the main agent logic. Search. PY for the SERPer API integration, summarizer. PY for the OpenAI summarization, ranker. PY for relevance scoring, exporter. PY for the report output, and a requirements, TXT file. Accept this structure. In Composer, reply, perfect. Please create all these files with placeholder code and comments describing what each section will do. Watch Cursor create an entire project skeleton in seconds. Now open the terminal at the bottom of Cursor using Control backtick on both Mac and Windows. You'll see a command prompt inside your project folder. Type this command. Pip install langchain OpenAI requests beautiful soup for python env serper-python. Press enter. This installs all the dependencies your agent needs. Watch the terminal output. If you see any red error messages, paste them into Composer and ask it to fix them. Next, we need to configure our API keys. In the project root, Cursor may have already created a env file. If not, type in Composer, create a env file with placeholders for OpenAI.key and serper.env. Then open the .env file in the editor and replace the placeholder values with your actual API keys. Get your OpenAI key at platform, openai.com, and your serper key at serper.dev. Both have free tiers that are enough for this tutorial. Here's a critical security step that beginners always skip. Make sure your .env file is listed in git ignore. In Composer, type check that env is in git ignore and add it if it's missing. This prevents your API keys from being accidentally pushed to GitHub and exposed to the public. One leaked API key can result in thousands of dollars in charges. Never skip this step. Now we build the brain of the agent. Click on Agent, PY to open it. In Composer, type Build the Research Agent class in Agent, PY. The class should have an underscore, init underscore method that loads API keys from the .env file, a research method that accepts a query string, and a run method that orchestrates the full research pipeline. Press Enter and watch Composer write the complete class structure with proper imports, docstrings, and error handling. Once Composer finishes writing agent, read through the code carefully. This is important. Don't just trust the AI blindly. Verify that the imports match your installed packages, that the API key variable names match your ngn file exactly, and that the methods are named as you specified. If you spot anything off, select the problematic section and use inline editing with Command K to fix just that part. Now let's build the search module. Click on Search, In Composer, type Build a search client class in Search, PY. It should use the SERPer API to search the web for a given query and return the top 5 results as a list of dictionaries, each containing title, URL, and snippet. Composer will write the complete SERPer integration, including the API call, response parsing, and error handling for rate limits and network failures. Test the search module immediately. In Composer, say, write a test function at the bottom of Search, IY, that searches for AI agents and prints the results. Make it runnable with Python search. Then open the terminal and run Python search. If results print out successfully, your search module is working. If you see an error, paste the full error message into Composer, the complete error, not just the last line, and it will diagnose and fix it. Open Summarizer. In Composer, type Build an Article Summarizer class. It should accept a URL, fetch the article content using requests and beautiful soup, then send the content to OpenAI GPT-4o Mini to generate a 2-paragraph summary focused on key insights. Include a method called summarize-URL that takes a URL and returns the summary as a string. This is the AI layer of your agent. where raw web content becomes structured intelligence. There's a common mistake here that wastes API credits. Sending the full raw HTML of a web page to OpenAI instead of the clean text. Beautiful Soup extracts the text, but sometimes it still captures navigation menus, footers, and ads. In Composer, type update the article fetcher to strip all HTML tags, remove lines shorter than 50 characters, and take only the first 3,000 words before sending to OpenAI. This simple filter cuts your token usage by 60%. Open Ranker. P. In Composer, type build a relevance ranker class. It should accept the original research query and a list of article summaries. It should use OpenAI to score each summary on a scale of 1 to 10 based on how directly it addresses the query. Return the summaries sorted from highest to lowest score. This scoring step ensures your final report surfaces the most relevant information first, not just whatever happened to rank highest in the search. Once Composer writes the ranker, ask it immediately. Add a fallback for when OpenAI returns a score that is not a valid number. The fallback should assign a score of 0 and log a warning. Always think about edge cases when building agents. The difference between a hobby project and a production system is how well you handle the unexpected. Open Exporter. P. In Composer, type build a report exporter class that accepts a research query, a list of ranked summaries with their scores and source URLs, and a timestamp. Should format this data into a clean, readable research report and save it to report.txt. Include a table of contents at the top, numbered sections for each source, and a summary of key themes at the end. This is what gets delivered to the user at the end of the agent run. Let's add a professional touch to the exporter. In Composer, say, update the report exporter to also print a formatted preview of the report to terminal when it's done, showing the title and the top 3 results. This real-time feedback lets users see progress without having to open the output file every time they run the agent. It's a small detail that makes your tool feel polished. Now we tie everything together in Agent. PY. In Composer, type update the run method in Research Agent to call Search Client. Then call Article Summarizer for each URL. Then call Relevance Ranker to sort the results. Then call Report Exporter to save the final report. Add print statements at each stage, showing progress like searching, summarizing Article 1 of 5, ranking results, saving report. This pipeline is the heartbeat of your AI agent. This is a great moment to introduce the concept of agent state. In Composer, ask, add a self-state dictionary to Research Agent that tracks the current stage, the number of articles processed, and any errors that occurred. Update the state at each step of the pipeline. State tracking is what separates amateur agent code from production-grade systems. It enables debugging, resuming failed runs, and building dashboards later. It's time to do the first full test. In the terminal, type Python agent, PYY, and when prompted, enter the topic, Best AI Coding Tools 2025. Watch what happens. The agent searches the web, fetches articles, calls OpenAI to summarize each one, ranks the summaries, and writes a report. TXT file. This is your AI agent running live. Take a moment to appreciate what just happened. You built this from scratch. After the test run, open report, TXT, and read through it. Does the content make sense? Are the summaries relevant to the query? Is the ranking reasonable? Rate the output honestly. In Composer, describe any issues you see. The summaries are too long, and the ranking scores seem arbitrary. Please adjust the summarizer to limit responses to 100 words and improve the ranking. Prompt to be more specific about relevance criteria. Iterating on output quality is a core skill. Let's add async execution to speed up the agent. Right now, it summarizes articles one at a time, which means 5 API calls in sequence. In Composer, type refactor the summarization step in Agent, PY, to use Python async IO and process all 5 URLs concurrently instead of sequentially. Preserve error handling for each individual URL so one failed fetch doesn't break the whole run. This change reduces total runtime from 30 seconds to about 7 seconds. 4 times speedup with one composer prompt. Add a caching layer so the agent doesn't repeat API calls for the same URL. In Composer, say, add a simple JSON cache to article summarizer. Before calling OpenAI, check if a summary for this URL exists in cache, JSON. If it does, return the cached version. If not, call OpenAI, cache the result, then return it. Caching is essential for production agents. It saves money, speeds up repeat queries, and reduces API rate limit errors. Now let's add memory to the agent. Memory allows the agent to reference previous research sessions. In Composer, type Create a Memory Py module with an agent memory class that loads and saves research history to a JSON file called memory.json. Add a method called get.relationContext that accepts a new query and returns the 3 most semantically similar past research topics from memory. Memory transforms a stateless script into a genuine AI agent. Add a command line interface so the agent feels professional. In Composer, say, add a CLI to agent, PY, using ardparse. Support 3 flags, query for the research topic, max results for how many articles to process, default 5, and output for the report file path, default report.txt. Also add a -verbose flag that shows detailed logging during the run. With a CLI, your agent can be called from other scripts, scheduled as a cron job, or wrapped in a web interface. Let's talk about how to monetize this agent. Option 1 is freelance services. Research agents like this are in enormous demand right now. Market research firms, content agencies, and law offices all need automated research tools. Package your agent as a deliverable. Charge $200 to $500 per custom deployment, and you have a solid freelance product. Option 2 is a SaaS wrapper. Take the agent you just built, wrap it in a simple Flask or Fast API web server, add a user authentication layer, and you have the backend of a SaaS product. Charge users $15 to $50 per month for access. In Composer, type, create a Fast API wrapper for Research Agent with 2 endpoints, post/research, that accepts a query and returns a job ID, and get/results/job ID that returns the report when ready. This transforms your script into a web service in minutes. Option 3 is automation consulting. Many businesses want AI agents but don't know where to start. You now have the skills to build custom research, content, and analysis agents for specific industries. A research agent for a real estate firm, a competitive analysis agent for a marketing agency, a due diligence agent for a venture capital firm. Each of these is a $5,000 to $20,000 consulting engagement. Let's talk about business applications beyond the demo. The research agent architecture you just built is the foundation for dozens of vertical-specific tools. Add a few lines of prompt customization, and you have a legal research assistant that summarizes court cases, a market intelligence tool that tracks competitor pricing, or a medical literature reviewer that synthesizes clinical studies. The business model that scales fastest with this architecture is the white label approach. Build one well-tested research agent. Customize the prompts, branding, and export format for each client. Deploy it as a private tool under their brand. Charge a setup fee plus a monthly maintenance retainer. One code base, multiple revenue streams, minimal ongoing development work. Let's automate the agent to run on a schedule. In the terminal, type crontab-e on Mac or Linux. Add this line, 09 times 1 CD, your project path, and Python agent. PY, Shax query, weekly industry news. Output weekly report. TXT. This runs your agent every Monday at 9 a.m., automatically producing a fresh research report. Replace the query with whatever your client needs, tracked weekly. For Windows users, use Task Scheduler to achieve the same result. Open Task Scheduler. Create a new basic task. Set the trigger to weekly on Monday at 9 a.m. and set the action to run Python with your agent. PyScript as the argument. Now your agent is running autonomously, delivering reports without any human involvement. This is what people mean when they talk about passive income from AI tools. Here's an expert strategy most tutorials never teach. Chain your agents. The research agent you built can feed its output directly into a second agent. For example, a content writing agent that turns the research report into a blog post, or a presentation agent that converts the findings into a slide deck. In Composer, type Create a Content Agent class that accepts the research report text and uses OpenAI to transform it into a 1,500-word SEO-optimized blog post. You've just created an AI pipeline. Another expert strategy is adding human-in-the-loop approval steps. After the search results come in, but before the summarization begins, pause the agent and ask the user, "Found these 5 articles. Do you want me to proceed or skip any of them?" In Composer, say, add an interactive approval step after search results are retrieved, showing the user the article titles and asking for confirmation before proceeding. This turns your fully automated agent into a supervised agent, which is often what paying clients actually want. Expert strategy number 3. Instrument your agent with metrics. Track how long each step takes, how many tokens each API call uses, and what the total cost of each run is. In Composer, type Add a metrics collector class that records start and end times for each pipeline stage, token counts from OpenAI API responses, and estimated costs at current API rates. Print a cost summary at the end of each run. Knowing your cost per run lets you price your service profitably. Let's cover the 5 most common mistakes when building AI agents in Cursor. Mistake number 1. Not setting a maximum token limit on API calls. If an article is very long, your summarizer might try to send 100,000 tokens to OpenAI, costing several dollars for a single summary. In Composer, type Add a hard token limit of 4,000 tokens to every OpenAI call in Summarizer, Pi, and truncate input content to fit within this limit. Always cap your token usage. Mistake number 2. Ignoring rate limits. If you process 5 articles concurrently and you're on OpenAI's free tier, you will hit rate limit errors immediately. In Composer, say, add exponential backoff to all OpenAI API calls. If a rate limit error is received, wait 2 seconds, then 4, then 8, before retrying up to 3 times. This makes your agent resilient to rate limiting without requiring a paid API tier. Mistake number 3. Not validating the search results before processing them. Sometimes SERPer returns results without a valid URL, or the URL returns a 404 error. In Composer, add, before passing a URL to the summarizer, validate that it returns an HTTP 200 status code. Skip any URL that doesn't, and log it as unavailable. A single bad URL can crash your entire pipeline without this check. Mistake number 4. Storing API keys in your code files instead of in environment variables. This is the most dangerous mistake. If you ever share your code or push it to GitHub, your keys are exposed. Always use .tem. Never hardcode keys. In Composer, ask, audit all files in this project, and flag any hard-coded API keys or secrets. Replace them with environment variable references. Do this audit before sharing your code with anyone. Mistake number 5. Not logging. When your agent runs in production and something breaks at 2 in the morning, you need a log file to understand what happened. In Composer, type Add Python logging to all modules. Log at the info level for normal operations, warning level for non-critical issues, and error level for exceptions. Write all logs to agent. Log with timestamps. Logging is the difference between debugging in minutes and debugging for hours. Let me show you 3 hidden cursor features that most users discover only after months of use. Feature number 1, the @ symbol context menu. In any cursor chat or composer prompt, type @ and you'll see a menu that lets you reference specific files, folders, documentation websites, GitHub repositories, and even the output of terminal commands. Type @docs and enter a documentation URL. Cursor will read that documentation and use it when answering your questions. This is how you teach Cursor tools it's never seen before. Hidden feature number 2, Cursor notepads. Open a new notepad in Cursor by going to the View menu and selecting Notepads. A notepad is a persistent context document that you can reference in any prompt using the @ symbol. Put your project architecture, your coding standards, your API documentation, and your business requirements in a notepad. Now, every composer prompt automatically has access to all this context. This is how senior engineers use Cursor differently from beginners. Hidden feature number 3, the Cursor Agent Mode. In Composer, click the drop-down next to the Send button and select Agent Mode. In Agent Mode, Cursor doesn't just write code. It runs the code, reads the output, identifies errors, fixes them, runs again, and iterates until the code works. For complex agents like the one we built, this can complete entire development cycles without any human intervention. Turn on Agent Mode now and type, "Run the full test suite for our research agent," and fix any errors automatically. Watch it work. Cursor is evolving incredibly fast. In 2025 and into 2026, several new capabilities are being rolled out. First is direct computer use integration, where Cursor agents can interact with your operating system, opening browsers, filling forms, taking screenshots, without any additional code from you. The second is team workspaces, where multiple developers and AI agents collaborate on the same codebase simultaneously. The third upcoming capability is native MCP server integration, which allows Cursor to connect your agent directly to databases, CRMs, payment systems, and APIs without writing any integration code. This means the research agent we built today could automatically save its findings to a Notion database, send a Slack notification, and create a Salesforce opportunity record, all from a single composer prompt. Here is your action plan for the next 7 days. Day 1. Complete this tutorial and get your research agent running locally. Day 2. Add async processing and caching to your agent. Day 3. Wrap it in a fast API web server using the pattern we discussed. Day 4. Deploy it to a cloud server, Railway, Render, or Fly. I/O all offer free tiers that work for this project. Day 5. Create a simple landing page describing what your agent does and who it's for. Day 6. Share your agent in 3 places: the Cursor Discord, the LangChain community, and LinkedIn. Describe what you built, what problem it solves, and that you're available for custom implementations. Day 7. Reach out to 5 potential clients directly: marketing agencies, research firms, content studios, and offer a free demo. This is how you convert a weekend project into a revenue stream. You have just built a fully functional, production-ready AI agent using Cursor. You now know how to plan agent architecture, build modular Python components, integrate real APIs, handle errors, optimize for performance, and monetize your creation. 6 hours ago, this might have felt impossible. Now you have working code, a monetization strategy, and a 7-day action plan. The people who will thrive in the next 5 years are not necessarily the ones who understand AI the deepest. They're the ones who can build with AI the fastest. Cursor gives you that speed. The agent you built today is version 1. Every time you run Composer, you get better. Every project you ship teaches you something the next prompt can't. Start building. The world is genuinely waiting for what you're going to create. If this masterclass gave you clarity and confidence to build with Cursor, do one thing right now. Open Cursor, type your first Composer prompt, and don't stop until you have something running. The code is the teacher. Everything else is just preparation. Go build.